Hello, my friend. Welcome to my channel. So today I'm going to talk about a problem related to hypothesis testing for population mean. This is the example. A researcher reports that the average salary of assistant professors is more than $42,000. A sample of 30 assistant professors has a mean salary of $43,260. At alpha equals 0.05, test the claim that assistant professors earn more than $42,000 per year. The standard deviation of the population is $5,230. So let's identify the claim in this hypothesis testing. So test the claim that the assistant professors earn more than 42,000 per year. So let's write the null hypothesis, which is H naught, and the alternative hypothesis. So the alternative hypothesis is the claim here. The claim is more than 42,000. So we are looking at the sample mean, which is mu greater than 42,000. So this is your claim. And then the null hypothesis is equal. Mu equals 42,000. And now let's identify all the information here. The sample size M equals 30 and the sample mean X bar equals $43,260. And then the standard deviation of the population, which is sigma value, is given 5,230. So this is known. Therefore, we can use z-scores. Okay. Now, alpha value, which is the significant level, is 0.05. So we are going to use this alpha to decide the null hypothesis or the alternative hypothesis. Let's first calculate the test statistic. So the test statistic for this problem is X bar minus mu over sigma over square root n. So this is how you calculate your test statistic for this problem. X bar is $43,260 minus mu value is the hypothesized value, which is 42,000, divide by 5,230, divide by sample size is 30 square root. So the value of this test statistic is 1.32. So now, as you know, there are two methods to make a decision. One method is the critical value method, which is the traditional method, and the other method is the p-value method. So I'm going to do both methods. So let's look at the critical value method. So you need to find the critical value in this case. Alpha is 0.05. As you can see, this is a right tail test. So this is right tail test. So we are looking at the higher values here, right? Greater than 42,000 values. So therefore we are in the right tail test, okay? So alpha is in the right tail here. So this area under the curve in the right tail is 0.05. Then you know we need this critical value. So this is your critical value. And you know this area is 0.95 because the tail is 0.05 and the rest of this graph is 0.95. So to find this critical value, you can look at the Z table. So locate the closest number to 0.95 from here inside the table. You will see it is 0.9505 is the closest area to this. And then locate the Z-score. the z-score is 1.6 and the second decimal place is 0.5. So this critical value is 1.65. So if you have a number falls over here, then do not reject. If you have a number falls in this critical region, this is your critical, this region is your critical region. If you see any number falls in this area, then we are going to reject. So that is the critical value method. So you have the critical value here. Now let's look at the p-value method. So the p-value is the probability of getting extreme sample statistics when the null hypothesis is true. So that is the p-value is this. The probability z-scores greater than, since we are in the right tail, so extreme values are the z-scores greater than your test statistic. So this is exactly same as like the sample statistic, which is your x bar greater than 42,000. So this probability, these two probabilities are equal. So we are looking at the extreme cases when the null hypothesis is true. So let's calculate this value. Z greater than Z naught value is 1.32. So that is you are looking at the area. Let's say this is 1.32. All the Z scores greater than. So you are going to find this area. So that is your p-value. So if you look at the z-score table, 1.3 and the second decimal place over here, and you will see that area is 0.9066. So that is this 0.96 area, this area. But you need this area. So you need to subtract 1 minus 0.9066. So this value is 0.0934. So this area is 0.934, right? So your p-value, the probability z-scores greater than 1.32 is 0.0934. Now let's make the decision of this hypothesized testing. I'm going to use the critical value method. So my critical value is 1.65. I'm going to compare this value with my test statistic value 1.32. Which one is bigger? As you can see, my critical value is greater than my test statistic. That is, my test statistic value falls in this region around here, 1.32. Because 1.32 is less than 1.65. So the decision is we fail to reject the null, which is H naught. We fail to reject H naught according to critical value method. Now let's look at the p-value method. As you can see, this is my p-value and you have to compare your p-value with alpha value, which is 0.05. So as you can see, your p-value is greater than your alpha value. So if you look at the graph, suppose this is your alpha. Area under the curve is 0.05, which is your alpha. But if you look at the p-value, that area in the right tail is bigger than 0.05. That is your p-value is like this. So your p-value is larger than your alpha value, right? So in this case, we fail to reject the null, which is H naught. Now you can write the conclusion of this hypothesized testing. So there is not enough evidence to support the claim. So we don't have enough evidence to support the claim because we fail to reject H naught. That means we have to accept the null hypothesis and we have to reject the alternative hypothesis. That means there is not enough evidence to support the claim that the claim is professors earn more on average than $42,000 a year. So this is how you write your conclusion according to your decision of this hypothesized testing. So I hope you understand these problems. Here we use two methods, critical value method and the p-value method. And as you can see, the decision was same for both methods. And then the conclusion. So if you have any questions or concerns about this, please comment, and thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.